Hello guys, welcome to today's class where we'll be looking at the second method we use to solve our binomial theorem questions. So this method is known as what? The combination method. I'm sure it sounds familiar from the previous classes where we did permutation and combination. Now, combination method also applies that formula we use during whilst we were doing our permutation and combination. So the combination method is basically another method we can actually use to derive our binomial coefficient. So in solving, in expanding by questions on binomial theorem, whether we use Pascal triangle or combination method, the idea is actually the same thing using both of them. The only difference between the Pascal triangle and the combination method, which is the major and only difference, is that the methods of deriving the binomial coefficients are different. For Pascal triangle, we already have stated out coefficients for each of the powers, but for combination method, we derive these powers ourselves from our knowledge of combination. Then we'll be showing how we can actually work with that shortly. Now, for combination, first of all, we have to remember our formula for combination, as we'll be applying it very often. We have n factorial. When we remember our use of factorial, we say n factorial, n combination r gives us n factorial over n minus r factorial, r factorial. So this is what we mean by combination method, and this is the formula we'll be implementing in these studies. Another thing we need to know is that aside the fact that combination method and Pascal triangle method of deriving binomial coefficients are almost alike, or that is what they do are alike because they actually do the same thing. Now, the combination method is actually a more thorough method of deriving the binomial coefficient. Why? Because the combination method can be used to derive binomial coefficients for even negative powers, fractional powers. In fact, negative fractional power. That is, if you look at the Pascal triangle, we only use the Pascal triangle to expand binomial expressions with powers that are integers. In fact, specifically positive integers. That is, when you have a power like raised to the power 2, raised to the power 4, raised to the power 5, raised to the power 10, we can use the Pascal's triangle or quite alright. But when we have powers or integer or indices like your fractions or negative values, we cannot use the Pascal's triangle. So the Pascal's triangle is only and specifically for just powers of positive integers. But when you have other types of powers, that is like fractions, like decimals, like fractions, like decimals, like negative values, we are only allowed to use the combination method. Now, the combination method can be used for that, as well as also the positive integers. So we can easily just see the combination method as an all-round method used to solve every one of them, whether be it positive integers, negative integers, or fractional integers as powers. So the combination method is like an all-round method used to solve binomial expansion. So in the next class, we'll be taking examples on how you can actually apply this formula in solving questions, that is, in deriving the binomial coefficients of particular binomial theorem expansions. See you next class.